Good morning, dear students. As I said, we'll have a very interesting last topic of this chapter, units and measurement. I took a slow, steady process because physics should be taught in a very systematic way. As I said, the chapter is all about measurement and units. Physics is all about measurement, and when you measure certain thing, you are going to express into some parameter. It is called a unit. Okay, what is today's discussion? The relation says that deducing the relations, deducing the relation between physical quantities. Quantities. What exactly is this small heading? I just want to have a relation among physical quantities. It is called deducing means generating or constructing mathematically. Think that force, how force is defined. Let me take an example. Force is defined in terms of mathematically mass into acceleration, or kinetic energy is defined in terms of mass into velocity square. Or let me take one more, pressure you studied in liquids. The other book, second book, where pressure of a liquid is expressed in terms of density of a liquid, rho gh. Rho means density, g means gravity, h means height. So in one way, I mean to say, physical quantities, the product of three physical quantities gives another physical quantity. It means density, gravity, height gives pressure, your force equal to mass into acceleration. What I mean to say, we are going to learn how relations are constructed. Now take an example here. Its example is your simple pendulum. Example is simple pendulum. When you talk about simple pendulum, you can think in this way. This is one end is clamped, it is just here, and this is a bob. Think its length is L, its mass is M. Now it is going to oscillate. It is going to oscillate means yes. So if it starts here, it goes to motion, then comes back to same part, it is called one oscillation. I repeat, now you have a string of length L, mass M, and there is a gravity. Nobody present means gravity is present. Gravity means acceleration due to gravity, which is always attractive in nature. Okay, gravity with G value. So when one end is clamped to the rigid fixed support, the other end you have a bob, it is called bob of mass M. So when it oscillates, take now bob is here. It goes to motion, comes back. Once it goes and comes back, it is called one oscillation. One oscillation. What is oscillation? Oscillation means you start, take example, you start from your home, you come to the college and go back to the home. It is called one complete oscillation. What I mean to say, you started at a point, you go and reach and come back to the same point. It is called one oscillation. Yes. How much time is needed to complete one oscillation is called time period. I repeat, the time taken by the bob to complete one oscillation is called time period. We are interested in time period. We are interested in time period. I just want to know how this time period of a simple pendulum is dependent on length, dependent on gravity, dependent on mass. There are three parameters. How time period depends on length, depends on gravity, depends on mass. I don't know how my time period, physical quantity, a measurable quantity. What is measurable quantity? The time taken by the simple bob, simple pendulum bob to undergo to and fro motion. It's called to motion and fro motion. When it happens, what is the time taken? If time taken is some numeric value, you are going to calculate. So it depends on length. How it depends on length? Whether it is directly proportional or indirectly proportional. Whether mass is directly proportional or inversely proportional. Gravity, directly proportional or inversely. What I mean to say directly means time period increases with increase in mass. With increase in length, time period increases. If length decreases, time period increases. Opposite vice versa, we call it as inversely proportional. Means there are two options. Take example, there are three parameters: length, gravity, mass. How these three physical quantities of a simple pendulum are linked to time period. Are they directly proportional? Are they indirectly proportional? I don't know. Sorry. Let me say time period is directly proportional to length. Time period is directly proportional to mass. Time period is directly proportional to gravity. We don't know whether the power is positive or negative. Let me take the power as x for length, y for gravity, and z for mass. It is arbitrary. Anything you can choose. Let me start. Let t is directly proportional to length raised to x, gravity raised to y, and mass raised to, mass means this mass raised to z. I hope it's visible. Yes. Let time period is directly proportional to length raised to x, gravity raised to y, mass raised to z. Now, once I remove this proportionality constant, the equation looks like this. Time period is equivalent to, so once I remove this, it is proportionality constant, I am going to write it as k. Some constant, it is called dimensionless constant, means it has no dimensions in mass, length, and time. Remember in the previous discussion, dimensions of a physical quantity: length is L, mass is m, time is T, temperature is Kelvin, amount of substance is mole, and electric current is ampere. In that way, there are 7 fundamental physical quantities. Their dimensions we have written. And now take the derived physical quantity force. Its dimensions are mass into acceleration. Mass means m, acceleration means L t raised to minus 2. Together it becomes m L t raised to minus 2. In that way, this k is called dimensionless, means it has no dimensions in mass, length, time, or any other physical fundamental quantity. Now, L raised to x, once again I need to write g raised to y, then m raised to z. So this is my fundamental relationship. Yes. Call it as 1. Now I know that time means its dimensions are, whenever I want to write this equation, I need to dimensionally valid. It should be valid, means LHS dimensions should be equal to RHS. When I want to cross check this LHS equal to RHS, I am going to write the dimensions of LHS. The time dimensions are mass raised to 0, length raised to 0, time raised to 1, left hand side. I have written. This dimensional formula is for time period. Right hand side, k is a constant. It has no dimensions in mass, length, time. Hence I neglect. I'll be going for next. Length. Length dimension is L and its power is x. We don't know. Gravity means acceleration due to gravity. Let me write. G stands for acceleration due to gravity. When I say it's acceleration due to gravity, it is acceleration, means A equal to G. So this I'm going to write it as L t raised to minus 2. L t raised to minus 2. It is Y. Power is Y. For mass, it is mass. There is no other issue. Mass raised to Z. Now, when I look at left-hand side dimensional formula and right-hand dimensional formula, it is L raised to X, it is L raised to Y, and it is T raised to. So everything I need to simplify. What is the simplification? This equation simplifies to is equivalent to. Let me write L. L raised to X over. Then again you have L raised to Y. Then again you have T. It is minus 2 and Y. It becomes T raised to minus 2Y. That it gets over bracket. Finally, it is m raised to z. M raised to z. I think it's visible. Yes, everything is. Yes. Now let me take this example and finish it. Left hand side is m raised to 0, L raised to 0, T raised to 1. Left hand side. Right hand side, if I take it is L raised to X, L raised to Y, I can add the powers X plus Y. So for time, there is no time here. Time is alone. So it becomes T raised to minus 2Y. Mass is also alone, M raised to Z. So once I simplify further, it becomes, look at this now relationship. It is M raised to 0, L raised to 0, T raised to 1. So here, M raised to Z, L raised to X plus Y, T raised to. Looking into the powers, these powers are equated. It is X plus Y equal to L means 0. T raised to minus 2y equal to 1. M raised to z equal. Let me write. Z equal to 0. I equated this. M raised to 0 means M raised to Z means Z equal to 0. Now L. L raised to 0 means it is L raised to x plus y. Means x plus y is equal to 0. The first relation I got it. Z value I got. Then x plus y equal to 0 I got. Then finally minus 2y t raised to it is 1. This implies y equal to minus 1 by 2. So I got two values. I am interested in what are x, y, z. X, y, z are arbitrary values. X takes positive value. X, y, z may take positive, may take negative values. So what are they? They are the exponents of dimensions, mass, length, and time. Now I got z equal to 0, y equal to half. To make this identity valid, that is x should be plus half. Like if I substitute here, x equal to plus half, x equal to plus half, y equal to minus half, this becomes 0. Hence, I got the value x equal to plus half. All the three I got it. Z equal to 0, x equal to plus half, y equal to minus half. Once I substitute x, y, and z value into this equation, my equation becomes complete. Now, equation 1 simplifies to t equal to k is a constant. Let me write k constant. It is L raised to x. X means half. L raised to 1 by 2. Then g raised to y. G I need to write which y means minus half. Z m raised to z. I need to write m, but z value is 0. I'll be putting 0. So I got an equation time period equal to k times L raised to half, g raised to minus half, m raised to 0. This is one of the finest discussion. Let me take this, remove this part, or let me remove this part here, physical quantities. Yes. Now my final relation becomes, look at this relation. This whole equation, I'm going to write it here. Finally, I'm going to obtain time period equal to k. L raised to plus half means root of L. G raised to half, but minus half means the denominator it is G. M raised to nothing means I have this relation. Now time period is defined as k times under root L and in the denominator under root G. What we obtain? Finally, I obtain a relationship for time period which is directly proportional to root of L. I repeat, time period is directly proportional to root of L, inversely proportional to root of G, where k is a dimensional constant. In most of the time, k is taken as 2 pi. So sometimes we write time period is equal to 2 pi under root L under root G. So this completes our whole discussion. Let me take this example, 18 km per hour in terms of meter per second. Each kilometer is equal to 1000 meter. Similarly, each hour is equal to 60 minutes and each minute is equal to 60 seconds. So this becomes 60 seconds. Finally, we'll get the answer 3600 seconds. So I have an answer, 1 hour is equivalent to 3600 seconds. Let me write it here. Now let me take this example, 18 kilometer per hour. So I write 18 as it is. Kilo means already written here. It is plus 3 meter. Each kilometer means plus 3 meter. Denominator each hour equal to 3600 seconds. So you have 1 0 out, 2 0 out, it becomes minus 2. So you have 18 1 ja, 18 2 ja. It becomes finally 1 by 2. You have 10 raised to 3 minus 1, left with 10 raised to 1 meter per second. Then I can 10 raised to 1 means 10 is equal to 10 by 2 meter per second. 2 1 ja, 2 5 ja. Finally, the mathematics gives you 5 meter per second. Means you need to write it as 5 meter per second. Let me take a relative density of lead. We know that density is defined as density equal to mass upon volume. What is relative density? Relative density is equal to density of lead divided by density of water. They have given relative density, that is 11.3 is equal to density of lead. I know what is density of water, 1000 kilogram per meter cube. So I want a density of lead. Now density of lead is equivalent to this 11.3 into this becomes 1000, 10 raised to 3 kilogram per meter cube. If somebody asks me what is this answer, I can easily write here, or density of lead is equivalent to 11.3 into 10 raised to plus 3 kilogram per meter cube. The first part over. Now you want this. We know that 1 kilogram equal to 1000 gram. Similarly, 1 here meter equal to 100 centimeter. So I want to convert into gram and centimeter. 1 gram equal to 1 kg divided by 1000. This I can write it as mathematically 10 raised to, it becomes plus 3 becomes minus 3. Minus 3 kilogram equal to 1 gram. You need to remember this mathematics. Now similarly 1 centimeter equal to minus 2 meter. Similarly 1 centimeter, I am talking about this relation now. 1 centimeter equal to minus 2 meter. So again you remember this relationship. Using these two I can calculate this value because I had this value. Now density of lead is equal to 11.3 into plus 3. You have a kilo. So let me write it kilo here. Yes, kilo means I've written already 1 kilo equal to 10 raised to 1000. Again 1000 grams. Then again per meter, you write it meter. 1 meter equal to 100 centimeter. You write it 100 means plus 2 centimeter a cube because it is in denominator. Now when I simplify this, you'll get plus 3 plus 6. Here also plus 6. You can remove it. Let me write it directly. This gives you 11.3 into 10 raised to 6 gram. In the denominator 10 raised to 6 centimeter cube. Both will enjoy. Left with the answer. Here 11.3 gram per centimeter cube. This is your answer. Yes. We just calculated density in terms of what is this value means? 11.3, 10 raised to nothing, only this much. 11.3 gram per centimeter cube. I repeat, density of lead is 11.3 gram per centimeter cube, or it is this value, the bigger value. 11.3 into 10 raised to 3, you can call 11,300 kilogram per meter cube. I think, I hope this session was good and meaningful. Thank you. I will end the session.